Hello everyone, welcome to Let's Crack UPSC CSE English. In today's session, friends, we will continue with the fundamentals of geography. Now, as we have discussed the landforms in our previous session, so let's continue with the remaining topics. Yes, fundamentals of physical geography. Now friends, we have covered the unit 1, that is geography as a discipline, the earth, where we have discussed the origin and evolution of the earth, interior of the earth, distribution of ocean and continents. Now we are discussing landforms, where we have covered minerals and rocks, geomorphic processes, landforms and their evolution we are studying right now. Now, just recap what we have covered in this landforms and their evolution. Yes, so friends, in this chapter we have discussed about the landforms and their evolution. So before this chapter we have covered the weathering processes, which have had their actions on the earth materials. Like making up the surface of the earth. Now, there are involvement of geomorphic agents like running water, groundwater, wind, glaciers and waves. They perform the erosion. Now, it is already known to us that erosion causes changes on the surface of the earth. And then deposition follows erosion, and because of deposition too, changes occur on the surface of the earth. We have discussed about the running water in detail, like in humid regions which receive heavy rainfall. Running water is considered the most important of the geomorphic agents in bringing about the degradation of the land surface. There are two components of running water. One is overland flow on general land surface as sheet, or another is linear flow as streams and rivers in valleys. Most of the erosional landforms made by running water are associated with vigorous and youthful rivers which flowing over steep gradients. Now friends, with time, stream channels over steep gradients turn gentler due to continued erosion, and as a consequence lose their velocity, facilitating active deposition. So there may be depositional forms associated with streams flowing over steep slopes, but these phenomena will be on a small scale compared to those associated with rivers flowing over medium to gentle slopes. Then we have discussed about the characteristics of each of the stages of landscapes developing in running water, like we have discussed about youth, mature, old. Then we have discussed about erosional landforms, where we have discussed about valleys, potholes and plunge pools. Then incised or entrenched meanders, river terraces. Then we have discussed about depositional landforms, alluvial fans, deltas, then floodplains, natural levees and point bars. Then we have covered meanders in last session. So friends, in large flood and delta plains, rivers rarely flow in straight courses. So loop-like channel pattern called meanders, which develop over flood and delta plains. Now, after the meanders, we have discussed about the groundwater. So, where we have discussed about the work of groundwater in the erosion of land masses and evolution of landforms. The surface water which percolates well when the rocks are permeable, thinly bedded and highly joint and cracked. After vertically going down to some depth, the water under the ground flows horizontally through the bedding planes, joints or through the materials themselves. Now, it is this downward and horizontal movement of water which causes the rocks to erode. Now, physical or mechanical removal of materials by moving groundwater is insignificant in developing landforms. So basically that's why the results of the work of groundwater cannot be seen in all types of rocks. But in rocks like limestones or dolomites rich in calcium carbonate, the surface water as well as groundwater through the chemical processes of solution and precipitation, the deposition develop varieties of landforms. Now these two processes of solution and precipitation are active in limestones or dolomites, occurring either exclusively or interbedded with other rocks. So after that we have discussed about the pools, sinkholes, lapis and limestone pavements. Yes. Where friends we have discussed about the depositional landforms, salcatites, stalagmites and pillars, then glaciers, erosional landforms, where we have discussed about CQ, horns and serrated ridges. Then we have discussed about the highest peak in the Alps, Matterhorn, and the highest peak in the Himalayas, Everest, are in fact horns which form through headward erosion of radiating circuits. Then we have discussed this diagram in detail. The horn, RT, truncated spur, hanging valley, lateral moraine, medial moraine, terminal moraine and outwash plain. Then we have discussed about glacial valleys and troughs, depositional landforms, where we have covered the moraines, now moraines, eskers, outwash plains we have discussed. So basically outwash plain, the plains at the foot of the glacial mountains or beyond the limits of continental ice sheets are covered with glaciofluvial deposits in the form of broad flat alluvial fans, which may join to form outwash plains of gravel, silt, sand and clay. Now friends, drumlins. So drumlins are smooth oval shaped ridge like features which composed mainly of glacial till with some masses of gravel and sand. The long axis of drumlins are parallel to the direction of ice movement. Then these drumlins may measure up to 1 kilometer in length and 30 meter or so in height. So where the one end of the drumlins which facing the glacier, which call the stoss end, which is blunter and steeper than the other end, which is called tell. So stoss and tell are the ends of the drumlin. Then we have covered waves and currents. So now let's discuss about the high rocky coasts. Before that, dear friends, it's my pleasure to welcome you all on Unacademy, India's largest learning platform. It's me, Rushikesh Inamdar, guiding UPSC aspirants from last 8 years. You can follow me on Unacademy app, where friends, you can also join our Telegram group to get important updates related civil services preparation. Now, friends, today is the last day where we are providing you additional special discount 10% on UPSC CSE subscription. We will discuss the other features of this offer during the session. Now there will be price hike on UPSC CSE subscriptions. Before that, enroll for the UPSC CSE subscriptions. Now, friends, you can also enroll yourself for the mega combat which is scheduled on 19th September morning 11 am. The link is provided in the description box, so you can use invite code RBI Live to register for the mega combat. We are also providing Plus and Iconic paid subscription on our platform. Where friends, in Plus subscription you will get live classes, structured courses, unlimited access for live and recorded classes along with weekly tests. Now, those aspirants planning to appear for the preliminary examination after their graduation, means they are preparing for their graduation studies, or those who are planning to start their preparation after their 12th examination, they must go with Iconic subscription. In Iconic subscription, you will get all the features of Plus course along with additional features like personal guidance, study planner, study material, experts guidelines and test analysis. Now friends, you can go through the Iconic subscription. So in paid subscriptions, you will get 10% discount after using referral code RBI Live. Yes, RBI Live code you can use for the getting referral code discount. Now friends, after using the code, you have to pay only 44,550 rupees for the 1 year of Plus subscription and rupees 67,050 rupees for the 1 year of Iconic subscription. You can also avail 10% discount on optional subscription. And friends, do not forget to download Unacademy app. Just follow my profile, search my name in the search bar, follow my profile to get important updates, or basically the schedule of our special classes. Now friends, these free special classes which will help you to gear up your preparation. These are the basically interactive sessions where you can ask your doubts to our educators through live chat box. Along with that, you will get notes after the session in PDF form, and you can watch these sessions as per your convenience anytime, anywhere. Yes, so do not forget to download Unacademy app and start your preparation. When you are using the code RBI Live, you will get free content access on our Unacademy app, and you can able to watch all the sessions by are all educators. Yes. So friends, do not forget to attend the lectures on Unacademy app. So let's continue with the high rocky coasts. Yes. Now friends, along the high rocky coasts, the rivers appear to have been drawn with highly irregular coastline. Yes, highly irregular coastline. So the coastline appears highly indented with extension of water into the land, where glacial valleys, that is fjords, are present. The hillsides drop off sharply into the water. The shores do not show any depositional landforms initially. So, the erosion features dominate. Now, along high rocky coasts, waves break with great force against the land shaping the hill. So, the land shaping the hill sides into cliffs. So, with constant pounding by waves, the cliff recede, leaving a wave. Yes, the cliff recede, which leaving a wave cut platform in front of the sea cliff. Now, waves gradually minimize the irregularities along the shore. The materials which fall off and removed from the sea cliffs, they gradually break into smaller fragments and roll to roundness, will get deposited in the offshore. Now, after a considerable period of cliff development and retreat, when the coastline turns somewhat smooth, with the addition of some more material to this deposit in the offshore, a wave-built terrace would develop in front of wave-cut terrace. Now, the erosion along the coast takes place. A good supply material becomes available to long shore currents and waves to deposit them as beaches along the shore and as bars. So, long reaches of sand and shingle parallel to coast in the near shore zone. Bars are submerged features, and when bars show up above water, they are called barrier bars. Yes, good morning Ram Kumar. In today's session we are discussing about the remaining part of the fundamentals of physical geography. Now, dear friends, the erosion along the coast takes place. A good supply material becomes available to longshore currents and waves to deposit them as beaches along the shore and as bars in the near shore zone. So these bars are submerged features, and when bars show up above water, they are called barrier bars. Barrier bar which get keyed up to the headland of a bay is called spit. Now, when barrier bars and spits which form at the mouth of a bay and block it, where lagoons forms. So the lagoons would gradually get filled up by sediments from the land giving rise to a coastal plain. Now, low sedimentary coasts along low sedimentary coast, the rivers appear to extend their length by building coastal plains and deltas. The coastline which appears smooth with occasional incursions Yes. Next is low sedimentary coasts. After high rocky coasts, now we will see the low sedimentary coasts. Now friends, along the low sedimentary coast, the rivers appear to extend their length by building coastal plains and deltas. Now the coastline appears smooth with occasional incursions of water in the form of lagoons and tidal creeks. So the land slopes gently into water, then marshes and swamps may abound along the coasts. The depositional features dominate. So when waves break over a gently sloping sedimentary coast, the bottom sediments get churned and move readily, building bars. Then barrier bars, speeds and lagoons. So lagoons would eventually turn into swamp. Yes, the lagoons would eventually turn into swamp, which would subsequently turn into coastal plain. So the maintenance of these depositional features depends upon the steady supply of materials. Storm and tsunami waves cause drastic changes irrespective of supply of sediments. Now dear friends, the large rivers which bring lots of sediments which build deltas along low sedimentary coasts. Now, the west coast of our country is high rocky retreating coast. So erosional forms dominate in the west coast. The east coast of India is low sedimentary coast. So depositional forms dominate in the east coast. Yes. So the west coast of our country is a high, rocky, retreating coast. Now, let's discuss about the erosional landforms. So erosional landforms, where we'll discuss about the cliffs, terraces, caves and stacks. Now, friends, the wave cut cliffs and terraces are two forms usually found where erosion is the dominant shore process. So almost all sea cliffs are steep and may range from a few meters to 30 meters or even more. So at the foot of such cliffs, there may be a flat or gently sloping platform covered by rock debris. Derived from the sea cliff behind. So such platforms occurring at elevations above the average height of waves is called wave cut terrace. Now, the lashing of waves against the base of the cliff and the rock debris that get smashed against the cliff along with lashing waves create hollows, and these hollows get widened and deepened to form sea caves. Now, the roofs of caves which collapse and the sea cliffs recede further inland. Now, retreat of the cliff may leave some remnants of rock standing isolated as small islands just off the shore. Now, such resistance masses of rock, originally parts of a cliff or hill, are called sea stacks. Now, like all other features, sea stacks are also temporary, and eventually coastal hills and cliffs will disappear because of waves erosion giving rise to narrow coastal plains and with onrush of deposits which from over the land behind may get covered up by alluvium or may get covered up by shingle or stand to form a wide beach. Now, see the formation of cliff terraces, sea caves and sea stacks. Now, dear friends, in erosional landforms, where the sea stacks are also temporary and eventually coastal hills and cliffs will disappear because of wave erosion giving rise to narrow coastal plains, and with onrush of deposits from over the land behind may get covered up by alluvium or may get covered up by shingle or sand to form white beach. Now, depositional landforms. Next is depositional landforms. So friends, let's discuss about beaches and dunes. So beaches are characteristics of shorelines that are dominated by deposition, but may occur patches along even the rugged shores. So most of the sediment making up the beaches comes from land, which carried by streams and rivers, or from wave erosion. Now, the beaches are temporary features. Then the sandy beach, which appear permanent, may be reduced to very narrow strip of coarse pebbles in some other season. So most of the beaches are made up of sand-sized materials. So beaches called shingle beaches, which contain excessively small pebbles and even cobbles. Now just behind the beach, the sands lifted and winnowed from over the beach surfaces will be deposited as sand dunes. So the sand dunes forming long ridges parallel to the coastlines are very common along low sedimentary coasts. Now, See the bars, barriers and spits. Yes, after the beaches and dunes, let's discuss about the bars, barriers and spits. Now friends, a reach of sand and shingle formed in the sea in the offshore zone lying approximately parallel to the coast, which is called offshore bar. An offshore bar which is exposed due to further addition of sand is termed a barrier bar. Now, the offshore bars and barriers commonly form across the mouth of river or at the entrance of a bay. So sometimes such barriers bars get keyed up to one end of the bay when they are called spits. Now friends, the offshore bars and barriers which commonly form across the mouth of a river or entrance of a bay so sometimes such barrier bars get keyed up to one end of the bay when they are called spits. Now, spits may also develop attached to headlands, hills, so the barriers, bars and spits at the mouth of the bay gradually extend, leaving only a small opening of the bay into the sea, and the bay will eventually develop into lagoon. So the lagoons get filled up gradually by sediments which coming from the land or from the beach itself, and a broad and wide coastal plain may develop replacing a lagoon Yes, now see the diagram or satellite picture of a part of Godavari river delta which showing a spit. Now see the satellite picture of a part of Godavari river delta which showing a spit. So friends, in this satellite picture, as we discussed that the barriers, bars and speeds at the mouth of bay gradually extend, leaving only small opening of the bay into sea, and the bay will eventually develop into lagoon. Now, the lagoons get filled up gradually by sediments coming from the land or from the beach itself, with the help of wind, and broad and wide coastal plains. Yes. May develop, replacing a lagoon. Now, friends, the coastal offshores, yes, the coastal offshore bars offer the first buffer or defense against storm or tsunamis by absorbing most of the destructive force where yes, so the coastal offshore bars offer the first buffer or defense against storm or tsunami by absorbing most of their destructive force. Then come the barrier beaches, beach dunes and mangroves. So if any to absorb the destructive force of storm and tsunami waves. So if we do anything which disturb the sediment budget and the mangroves along the coast, these coastal forms will get eroded away, leaving human habitations to bear first strike of storm and tsunami waves. So let's discuss about the winds. Yes, now let's discuss about the winds. So wind, one of the dominant agents in hot deserts. The desert floors get heated up too much and too quickly because of being dry and barren. So the heated floors heat up the air directly above them and result in upward movement in the hot lighter air with turbulence. Now any obstruction in its path sets up eddies. Whirlwinds, updrafts and downdrafts. Now friends, winds also move along the desert floors with great speed, and obstruction in their path create turbulence. Now of course, there are storm winds which are very destructive. So the winds cause deflation, abrasion, and impact. So this deflation, which includes lifting and removal of dust and smaller particles from the surface of rocks. In the transportation process, sand and silt act as effective tools to abrade the land surface. Now the impact is simply sheer force of momentum which occurs when sand is blown into or against rock surface. Now it is similar to sandblasting operation. The wind action creates a number of interesting erosional and depositional features in the deserts. In fact, many features of deserts owe their formation to mass wasting and running water as sheet floods. Though rain is scarce in deserts, it comes down torrentially in short period of time. The desert rocks, devoid of vegetation, exposed to mechanical and chemical weathering processes due to drastic diurnal temperature changes, the decay faster, and the torrential rains help in removing the weathered materials easily. That means the weathered debris in deserts is moved by not only wind but also by rain, sheet wash. So the wind moves fine material and general mass erosion in, accomplished mainly through sheet floods or sheet wash. The stream channels in desert areas are broad, smooth, and indefinite and flow for a brief time after rains. Excuse me. So, this way the many features of deserts owe their formation to mass wasting and running water as sheet floods. Now, after winds we'll discuss about the erosional landforms. Now friends, erosional landforms, pediments and pediplains erosional landforms, pediments and pediplains. Now friends, the landscape evolution in deserts is primarily concerned with the formation and extension of pediments, gently inclined rocky floors close to the mountains at their foot, with or without a thin cover of debris, are called pediments. So gently inclined rocky floors close to the mountains at their foot, with or without a thin cover of debris, are called pediments. Now such rocky floors form through the erosion of mountain, yes, the erosion of mountain front, through a combination of lateral erosion by streams and sheet flooding, so erosion which starts along the steep margins of landmass or the steep sides of the tectonically controlled steep incision features over the landmass. Now once pediments are formed with a steep wash slope followed by cliff or free face above it, the steep wash slope and free face retreat backwards. This method of erosion is termed as parallel retreat of slopes through back washing. So through parallel retreat of slopes, the pediments extend backward at the expense of mountain front and gradually the mountain gets reduced, leaving an Inselberg which is remnant of the mountain. So that's how the high relief in desert areas is reduced to low featureless plains called pedeplains. So the high relief in desert areas is reduced to low featureless plains called pedeplains. Now, playas. So basically, plains are by far the most prominent landforms in the deserts, in basins with mountains and hills around and along. Yes, around and along. The drainage is towards the center of the basin due to the gradual deposition of sediment from basin margins. So, a nearly level plain which forms at the center of the basin. Now, in times of sufficient water, this plain is covered by a shallow water body. So such types of shallow lakes are called playas, where water is retained only for short duration due to evaporation, and quite often the playas contain good deposition of salts. So the playa plain covered up by salts is called alkali flats. Yes. Now, deflation hollows and caves. Now friends, weathered mantle from over rocks or bare soil, yes, weathered mantle from over the rocks or bare soil gets blown down by persistent movement of wind. Yes, wind currents in one direction. This process may create shallow depressions which call deflation hollows. Now, deflation also creates numerous small pits or cavities over rock surfaces. The rock faces suffer impact and abrasion of wind-borne sand, and first shallow depressions called blowout are created, and some of blowouts become deeper and wider fit to be called caves. Now, mushroom, table and pedestal rocks. After deflation hollows and caves, now let's discuss about the mushroom, table and pedestal rocks. Now friends, many rock outcrops in the deserts easily susceptible to wind, deflation and abrasion are worn out quickly, leaving some remnants of resistant rocks polished beautifully in the shape of mushroom with a slender stalk and a broad and rounded pear-shaped cap above. Then sometimes the top surface is broad like a tabletop, and quite often the remnants stand out like pedestals. Yes, mushroom table and pedestal rocks. Now see the many rock outcrops in the deserts easily susceptible to wind deflection and abrasion are worn out quickly, leaving some remnants of resistant rocks polished beautifully in the shape of mushroom with a slender star and a broad rounded pear shaped cap above. So sometimes this top surfaces is broad like a table, and quite often the remnants stand out like pedestals. Now, let's discuss about depositional landforms. Now friends, wind is good sorting agent depending upon the velocity of wind. Different sizes of grains are moved along the floors by rolling or saltation and carried in suspension and in the process of transportation itself. The materials get sorted when the wind slows or begins to die down. Depending upon sizes of grains and their critical velocities, the grains will begin to settle. So in depositional landforms made by wind, good sorting of grains can be found since wind is there everywhere, and whenever there is good source of sand and with constant wind directions, the depositional features in arid regions can develop anywhere. Now, this is depositional landforms, as wind is a good sorting agent depending upon the velocity of wind. Then different sizes of grains which are moved along the floors by rolling or saltation and carried in suspension and in this process of transportation itself, the wind materials get sorted. So when the wind slows or begins to die down, depending upon sizes of grains and their critical velocities, the grains will begin to settle. So in depositional landforms made by wind, good sorting of grains can be found, and since wind is there everywhere and wherever there is good source of sand and with constant wind directions, depositional features in arid regions can develop anywhere. Now let's discuss about sand dunes. So friends, the dry hot deserts are good places for sand dunes. Yes, for sand dune formation. Obstacles to initiate dune formation are quickly important. There can be a great variety of dune forms. Now, so basically the obstacles to initiate dune formation are equally important, and so there can be great variety of dunes. See, the crescent shaped dunes called Burchens with the points or wings directed away from wind direction, that is downwind, from where the wind direction is constant and moderate, and where the original surface over which sand is moving is almost uniform. Then parabolic dunes form when sandy surfaces are partially covered with vegetation. Sandy surfaces are partially covered with vegetation, parabolic dunes. Now, the safe is similar to Burchan with small differences. So where the safe has only one wing or point. So basically, these are the types of dunes. Now, Seaf has only one wing or point. So this happens when there is shift in wind conditions. The lone wings of Seafs can grow very long and high. So then longitudinal dunes which form when supply of sand is poor, and wind direction is constant. Now they appear as long ridges of considerable length but low in height, whereas the transverse dunes are aligned perpendicular to wind direction. So these transverse dunes are aligned perpendicular to wind direction, and these dunes form when the wind direction is constant and the source of sand is an elongated feature at right angles to the wind direction. They may be very long and low in height, and when sand is plenty quite often, the regular shaped dunes coalesce and lose their individual characteristics. Most of the dunes in the desert shift, and a few of them will get stabilized, especially near human habitations. Now see, this is the sand dunes. So in diagram, various types of sand dunes and the arrows which indicating the wind direction. Now, in in this chapter, we have covered about the high rocky coasts, then erosional landforms like cliffs, terraces, caves and stacks, then we have discussed about depositional landforms, beaches and dunes we have discussed, bars, barriers and speeds, then winds we have discussed in detail, then friends we have discussed about the erosional landforms, where we have covered pediments and pedeplains, so landscape evolution in desert is primarily concerned with the formation and extension of pediments. Then we have covered about playas, deflation hollows and caves, then mushroom table and pedestal rocks we have discussed. And after that, depositional landforms. And then we have covered sand dunes. Now friends, before moving to the next unit, that is climate, let's have a recap of last 3 units we have covered. In next unit we will discuss the atmosphere, insolation pressure, precipitation and world climates. So in the next session we will discuss about the atmosphere, that is the unit of climate we will start in next session, that is in next part. Now friends, I hope you are making short notes also. In first unit we have discussed about geography as a discipline, so where we have discussed about the importance of geography. So geography as a integrating discipline we have discussed. Then we have discussed physical geography and natural sciences. Then we have discussed geography and social sciences. So we have discussed about the field of geography like historical geography, that is history, social geography, sociology, geographical thoughts, philosophy, cultural geography as anthropology, environmental geography as environmental science, then human ecology as ecology, zoo geography as zoology, phytogeography as botany, soil geography as pedology, oceanography as hydrology, then climatology as meteorology, geomorphology as geology, mathematical and astronomical geography as maths and astronomy, then quantitative techniques in geography as statistic, econometrics, then economic geography as economy, population geography as demography, and political geography as political sciences. So we have discussed these field of geography in detail. Then branches of geography based on systematic approach. Then based on regional approach we have discussed the subject geography. Now friends, we have also covered the definition by geographers like by Richard Hartshorne, who described as geography is concerned with the description and explanation of the areal differentiation of the Earth's surface, where Hettner describes geography studies the differences of phenomena usually related in different parts of the Earth's surface. Then we have discussed about the Earth where we have covered the origin and evolution of the Earth. Like we have discussed the early theories, origin of the Earth, then modern theories where we have discussed origin of the universe. We have also discussed about the Big Bang theory, then star formation, formation of planets, Then our solar system we have discussed in detail. The moon, evolution of the earth, evolution of lithosphere, then evolution of atmosphere and hydrosphere, then we have discussed about geological time scale, and then yes, we have discussed this geological time scale, and then origin of life. So the last phase in evolution of the earth, which relates to the origin and evolution of life. So it is undoubtedly clear that initially the earth or even the atmosphere of the earth was not conducive for the development of the earth. The development of life. So modern scientists refer to the origin of life as a kind of chemical reaction which first generated complex organic molecules and assembled them. So the assemblage was such that they could duplicate themselves, converting inanimate matter into living substance. The record of life that existed on this planet in different periods is found in rocks in the form of fossils. So the microscopic structures closely related to the present form of blue algae have been found in geological formations much older than 3000 million years. So it can be assumed that life began to evolve sometimes 3800 million years ago, and the summary of evolution of life from unicellular bacteria to the modern man is given in the geological time scale. Yes. Then we discuss about the interior of the earth. Where friends, we discuss about the sources of information about the interior, where we have covered direct sources, indirect sources, So in direct sources, the most easily available solid earth material is surface rock or the rocks we get from mining areas like gold mines in South Africa are deep as 3 to 4 kilometers. So going beyond this depth is not possible at it is very hot at this depth. So then we have discussed about the indirect sources in interior of the earth. So the analysis of properties of matter which indirectly provides information about the interior. We know through the mining activity that temperature and pressure increase with the increasing distance from the surface towards the interior in deeper depths. Then we have discussed about the earthquake waves, primary waves, secondary waves, then surface waves we have discussed in detail. Then P wave shadow zone, S wave shadow zone. Then we have covered the structure of the earth, that is the crust, mantle, core, and then we have discussed about volcanoes and volcanic landforms. So shield volcanoes, cinder cone, composite volcanoes, caldera, flood basalt provinces, mid-ocean ridge volcanoes. Then we have covered the volcanic landforms like intrusive forms, batholiths, latholiths, lapolith, pacholith and silts we have discussed. Then we discuss about the dikes also. Then we have covered distribution of oceans and continents. Now friends, here we will discuss about the continental drift, evidence in support of continental drift. Tillit, placed deposits, distribution of fossils, force for drifting, post-drift studies like conventional current theory, mapping of the ocean floor. Then ocean floor configuration we have discussed. Continental margins. abyssal plains, mid-oceanic ridges we have covered. Then friends, we have discussed about distribution of earthquakes and volcanoes. Then concept of seafloor spreading. The ring of fire. Like we have discussed deep earthquake zones, shallow earthquake zones, yes, shallow earthquake centers, volcanic eruptions and hotspots. Then we have covered the plate tectonics and major and minor plates of the world we have covered. So the major plates like Antarctica and the surrounding oceanic plate, North American plate, South American plate, Pacific plate, India, Australia, New Zealand plate, Africa with the Eastern Atlantic floor plate, and Eurasia and the adjacent oceanic plate. These are the major plates. And minor plates like Cocos plate, Nazca plate, Arabian plate, Philippine plate, Caroline plate, Fuji plate. Now friends, these plates have been constantly moving over the globe throughout the history of the earth. Then we have discussed about the transform boundaries, rates of plate movement, divergent boundaries, force of the plate movement, convergent boundaries. And then we have covered the movement of the Indian plate. Then in third unit, landforms, we have covered minerals and rocks, where we have discussed the physical characteristics of minerals. Then metallic minerals, non-metallic minerals, rocks, igneous rocks, sedimentary rocks, metamorphic rocks, then rock cycle, then we have covered the geomorphic processes, where we have discussed about the diastrophism, volcanism, exogenic process, weathering, chemical weathering, physical weathering processes. Then biological activity and weathering we have covered. Then we have also discussed about the significance of weathering, like spatial effects of weathering, exfoliation, then mass movements, landslides, erosion and deposition we have discussed, soil formation, process of soil formation, then soil formation factors, parent material, topography, climate, biological activity and time we have covered. And then we have discuss about the landforms and their evolution. So in this chapter we have discuss about the landforms and their evolution. So the geomorphic agents like running water, where the landscape developing in running water, which summarize as youth, mature, old. Then erosional landforms, where we have discussed valleys, potholes and plunge pools. Yes, the Valley Kaveri river near Hogenikal Dharmapuri district of Tamil Nadu. Then entrenched Minder loop of River Colorado in USA. Then we have discussed about the incised and entrenched meanders, river terraces, and then depositional landforms like alluvial fans, then deltas, floodplains, natural levees and point bars. Then meanders we have discussed in detail, and today we have covered about the, yes, in last session we have discussed about groundwater in detail, then erosional landforms like pools, sinkholes, lapis and limestones. Yes, limestone pavements we have discussed. Then caves, depositional landforms, stalactites, stalagmites and pillars we have discussed. Then glaciers in details. And then we have covered erosional landforms like cirque, horns and serrated ridges. Then glacial valleys, troughs, Depositional landform, moraines, eskers, outwash plains, drumlines. Then we have discussed about waves and currents. In today's session, we have discussed about high rocky coasts, low sedimentary coast, erosional landforms like cliffs, terraces, caves, and stacks. Then depositional landforms, where we have discussed about beaches and dunes, bars, barriers, and speeds. Then we have discussed about winds, erosional landforms like pediments and pediplains, playas, deflation hollows and caves, mushroom, table and pedestal rocks, depositional landforms, and then sand dunes. So friends, this way we have covered the 3 units of class 11th NCERT. Now in next unit we will discuss about the climate. Now friends, that's it for today's session. So friends, today is the last day to get additional special discount of 10% on UPSC CSE subscription. So for the 1 year of plus combo subscription, you have to pay only 46,740 rupees, whereas for the iconic combo subscription, you have to pay only 63,989 rupees. So the special price week applicable till today midnight. So friends, hurry up, enroll yourself before price hike. Do not forget to register yourself for Mega Combat, which is scheduled on 19th September morning 11 am. You can use invite code RBI Live, where you will get amazing prizes and scholarships. There will be 56 questions and time allocated is 60 minutes. Those aspirants pursuing graduation or after their 12th examination, planning to start their preparation for civil services, they must go with iconic subscription. And friends, you can also use code RBI Live to get 10% discount. Friends, do not forget to download Unacademy app, where you can follow me there. Just go to the search button, find out the educator list. You can find out my name over there and follow my profile. You will get notifications of our free special classes. Yes, these free special classes which will gear up your preparation. These are interactive live classes. After the classes, you will get lecture notes in PDF form. And you can watch these sessions as per your convenience, anytime, anywhere. So friends, recently we have started new batches. So as per your convenience, you can join 1 year or 2 year batches. Those aspirants planning to appear for the preliminary examination in 2022, they can go with 1 year batch, and those who are planning to appear for preliminary examination in 2023, they can go with the 2 year batch. So friends, that's it for today's session. I hope you liked the session. Do not forget to like, share and subscribe Unacademy videos. See you in the next lecture with the remaining topic of this class 11th NCERT. Will start with the climate, important topic. Till the time, stay home, stay safe, get vaccinated and take care.